All right, so welcome back. Welcome back to this YouTube channel. So, in the last video, of course, we have learned about object detection. Right, so you have learned about object detection, right? How we can perform object detection, and we have also used YOLO V5 pre-trained model to detect cars. So that is a very good, cool project. So now in this video, I'm just going to okay. So in this video, we are from now on. I think yeah, from now on in this video, we are going to deal with a new type of data. First, I'm going to introduce you to new type of data, and then we are going to use machine learning models to um, learn, right. So learn patterns in this new type of data. So it is actually time series data. So what this data is it's actually some values or specifically numbers as we have come to computers, right? I'm just going to. So what is time series data is, some data that changes over time. Right? For example, let's say you have stock prices. Let's say you have a company called let's say Google, and then if you can plot out all these stock prices and just get a graph, right, or something like that, or maybe a dip, right? So let's say you have a graph. So of all the stock prices of Google since the beginning, let's say this is actually time series data, right? So we are having some data that is changing over time, right? So there is a component of change. So let's say you want to predict whether the Google stock is going to increase or decrease over the next, or let's say 5 years, right? Let's say you want to predict it, right? You may predict something like that. So this is the actual data. So this is the actual data that you already have, and let's say this is the data that you have predicted. You have predicted that the stock price will rise up. So this is the problem of time series analysis or time series forecasting. So it is actually trying to predict or trying to find a relation between the previous stock prices. So this is actually graph. This is time, by the way, and this is prices. SP stock prices. This is time. So over time, let's say 10 years. So yeah, it has on average increase, of course. And then we are going to using this data, using this past data that we have already have, we are going to predict the next data. So what is going to happen? That is the problem of time series forecasting. This is just one example of this one example application of time series analysis. For let's say even if you think about text, no, even if you think about text, even though it is not numerical values, even though each word we cannot consider each word as numerical value, and we cannot provide um, the meaning of these words in a numerical value. I'll explain you what that is. There is a concept of the embeddings, word embeddings, in which you can assign numerical values to text, and then these embeddings uh, contain some meaning of this word. So these embeddings are just updated. I'll explain you about that in probably in the near future. So even text is also sequential data, or time series data. I should not say time series, it's sequential data. So it is actually having some values that are going over time. So what happens is, let's say this word will be dependent on this word, and this word will also be this word will be dependent on this word. So every word is dependent on each other, and we can also predict the next word or determine the class of this sentence, let's say, or we can give an output for each word. So we can understand these words. So we have the ability to understand sequences, right? So we can understand, um, let's say the change in stock prices, or we can understand languages just because we can understand the relation between both of these words or values or numbers. So that is the idea of time series forecasting, to be able to build machine learning models or deep learning models that can be able to understand mainly the relation between two words, and hence after they can understand these words, we can actually use them to solve many problems. So before diving into the introduction of RNN, which is recurrent neural networks used to model time series data, first I'm going to tell you about some problems, right? Some applications or some types of applications So there is one to many, one to many. I'll explain what this is. There is one to many. There is many to one. There's this many to many. Right. So this is the three types of problems. As you might have guessed, one to many is nothing but the input. We only have one input, and we should predict multiple outputs. In that case, the input of our RNN is one, and we want to predict the next value. Let's say we want to predict the next value after that, and then we have many to one. So given a sequence of values or numbers or words, anything, we have to predict one class of this sequence. We have to predict some relation between these words, and some based on the training data, we have to, let's say, solve a problem by understanding specific features that are necessary to solve a specific problem. So in this, we have many to many. So I'm actually going to give you some examples. So one to many is nothing but, let's say, let's say word, let's say let's GPTs or generative modeling, or let's say language models. Like Chat GPT is actually one to many. We actually give you one input, or probably, yeah, it's actually generating many outputs. This one doesn't matter. We just give the starting token and it generate many. And then the second type, many to one. So these, so some examples of these are, let's say, sentiment classification. So it's actually wonderful application. Given a sentence, we have to predict whether the sentence is said in a happy mood, is said in an angry mood, or anything. So we can actually predict what is the meaning of a sentence in terms of what is the behavior of this or mood of this speaker when saying that sentence. We can actually do that. And there is also comment toxicity. It's actually a very wide use application, I believe. So given a comment, let's say, on the internet, we'll use machine learning to actually determine whether this is toxic or hate or something based on that. And then there is many to many. So many to many, let's say Google translations. You input sentence in English, and then you'll get a output sentence in French. So and understand here, the number of tokens or number of values in the input sentence that is in English can, there is no need of the input sentence to have same number of values as output sentence. For example, let's say I want to speak a sentence. I want to make a statement. Let's say the number of values or the number of words it takes to convey it in English need not to be equal to the number of words needed to be conveyed on, let's say, French language. So many to many, the input length need not to be equal to the output length. So okay, all right. So these are the main types of applications that we can develop using sequential or RNNs, or yeah, sequential models in general. All right. So now let's get into the idea of RNN. So if I introduce this problem to you, if I introduce this problem uh, to a student who have just learned about deep learning and neural networks, he might propose, right, a very simple architecture. He might just say, let's say we have this sequence, we have these numbers, or let's say stock prices. Let's say we have this stock price one. Let's say it's 1 2 3 4, just a linear function. Okay, so all right. So what I'm saying is that, so as I've told you, right. So let's say, wait a minute. So let's say we have some stock prices. So let's say we have, let's say Google stock prices. Sorry. Let's say we have Google stock price. Let's say they're just linear for now. Just think that they are linear now. Right. So 1 2 3 4 5 6. Let's just assume it. So what you might suggest is that, we'll just build a neural network, right, which takes in, let's say, this one, and it should predict two, right? So you might say that we could just build a neural network. Let's call this neural network. For now, for this video, for the case of notation, let's say this is our neural network. This symbol represents our neural network. Let's say we'll just input a number and gets an output 2. So let's say the input of this neural network is the previous token, right? And then the output is the next token. You might suggest that, right? You might have just suggested that after I've introduced you the problem, but I'll just tell you what are the drawbacks, what the drawbacks are. Yeah, you might suggest this, right? So at every let's say interval, let's say every periodic interval, you might say we can just input the previous value to a neural network that can find some relation between the previous and the past values, and could predict the next value. So I think this idea is that works to some extent. We can able to find the relation between two let's say consecutive values in the notion of time series. But but there is some drawback. There are a lot of drawbacks. I'll just explain what are the problems of this network. I'll just go back down. So let's say I'll just draw a graph for you. Let's say this is the graph. Again, let's say Google or Chat GPT or something. Let's say Google. This company has been for a long time. So let's say it started off from here, it increases from here, and let's say it comes down, and let's say it goes down. Let's say this is some I don't know. Let's say this is 1 or 2. Don't think of this as negative, because stocks cannot be negative. So let's say we goes down and then maybe come down, and here goes like that. So what I want to tell you that is that there is a periodic increase or decrease in the stock prices. For example, let's say there is one point here, and let's say I'll just mark the same points here. Let let's say all these have same y values, right? Sorry, same x values, right? Sorry, same y values, right? So if I just input this value to a neural network, that can find the patterns between the previous and the next value. If I input this value to a neural network, it will predict the same thing. If I input this value to the neural network, it will predict the same thing. And even if I input this, the neural network will output the same thing. So what I'm telling is that it cannot find the rise. So if you get a human and show a human this graph, the human should be able to predict that if a stock is bought at this place, then he will predict that the stock will go up. Why? Because of its previous values. Just because in the previous value, as the stock is rising up, you saw the last previous value, and therefore you can predict that the stock price is going to increase. So this ability to able to look at past data, what happens in the past data points, where are the features of the past data points, and the change in these data points, the values of these data points, the human should be able to detect the price is going up. That is why we should not use a deep neural network. A normal deep neural network should not be used, because it is not able to find actual change. A change is a change because it has changed from the past. So therefore we should build a network that can take its previous outputs, and then therefore able to predict the next value. So that is why we introduce you to a new architecture, new deep learning architecture. Yeah, you guess the name, RNN, recurrent neural networks, right? So that is RNN. So what this RNN does is, rather than having one input and one output model, right? So rather than having like that, we are going to have like time series prediction. So for we will use the same neural network, but we'll roll it up, and then we'll have many neural networks, but with same weights, right? So we'll have the same neural network. I'll just draw this for you, just so you can understand. Let's say this is a neural network. It has some weights and parameters, and what are we going to do is, I'm just going to so what I'm going to do is, I'm just going to take this output of this neural network and then feed it again, and then get the output, feed it again, get the output, and therefore do the loss function and all that. I'll just explain it to you. I'm just drawing some boxes here, right? So we have 4 boxes here. So each box will represent a neural network, a classic neural network that you have already known, right? And then each neural network, and the thing you should remember is that every neural network has the same weight. So intuitively, all these boxes are the same neural network. All this will capture the same relation. So everything will have the same weights. So like you're just taking the output of a neural network and feeding it to the exact neural network. So that is why I'm drawing these identical boxes, and each represent the same. All of these boxes represents neural networks with the same weights. right? And then what will happen is, let's say I have three inputs. Let's say I have three inputs, three stock inputs. In actuality, there will be a lot of inputs. At each step, at each of this box, I'll just input the new value. I'm going to draw this. I'm going to tell you what that is. I'm going to, let's say, for example, this is x0, x of 0, x of 1, x of 2, and x of 3. And then let's say at this value, we are going to predict a new value. We're going to predict x of 4 or y4, let's say, we are going to predict the next value essentially. So what I'm doing is here is I'm going to have the first block or the first part of this neural network. I'm going to say, right, so we are going to input the first stock value. Let's say I'm going to take this first stock value. I'm going to do some calculations. The calculation, what is the calculation? Well, the neural network calculation. And look, we are not going to have an output. We are not going to predict an output. But what we are going to do is the patterns learned in this neural network, right, so will be shared or will be delivered to the or outputted to the next neural network. So we are just like each neural network finds some features and patterns of that data x0, and then we are going to share this new patterns hidden feature to this next part or next unit. Right, we are going to share this hidden output of the first layer or the first unit to the next unit. And then along with that, we are also going to have x1. So at each for each neural network in each unit, we are going to have two inputs, right, x0 and the hidden feature. For the first unit, we don't have two inputs, we only have one input. But from the second to the last unit, we are going to have two inputs, x1 and also the hidden feature or hidden output, I should say, of the previous layer. So therefore, this model or this unit will not only have the idea of x1, but also will have the structural idea of x0, what x0 is and what it represents and all that, the hidden feature of the neural network of x0. And then we are going to continue to do that until we get to the last layer. So this is a many to one problem. We'll have many inputs, many values, and then we are going to either predict the next value or take that. And so this is mainly to one problem. In the case of stock price prediction, so in the case of stock price, let's say we want to predict the next value, like the literal next value. In the case of stock price prediction, we are going to have an output. So you can also have this y1. Let's say this is y2. This is y3, right? So what I'm going to do is, rather than only taking x1 and the hidden unit, I'm also going to give the output of this x1. All right, so I'm just going to elaborate this further. In the case of stock price prediction, where you have to just find the literal consecutive value. So I'm just going to explain you that in a bit of detail. So let's say we have this. Let's say we have this data. Let's say for simplistic cases, let's just say take 1, 2, 3, 4, 5. So let's say we have 1, 2, 3, 4, 5, 6. In the case of stock price prediction, while trading, I'm going to talk about trading now first. So let's say you are given with 1. While training, you are going to predict 2. We are going to take in 1 and predict 2. And then after predicting 2, we are going to take both of these values and going to predict 3. And then after predicting 3, we are going to do that. So that is how training process happens. While training, while testing, you don't have to, right? I'm just going to go up. So while testing, you don't have to predict at each step. You only have to predict at the last step. While validating, well, you actually don't know what the next value is. And while training, what you can do is you can just have one output at each unit, and then you can just given 1 you should predict 2, and then given 1 and 2 you should predict 3, and so on. I'll show you how that happens. So what we're going to do is, at every step we are going to predict an output y0, and then we are going to further input this y0 also into this next step, and then also the hidden unit and the x1. So we are going to have all of these values. Understand? Sorry, we are not going to have x0. I'm going to erase that. I'm going to erase. Sorry, we are not going to have x0. Right. So here in the training phase. Sorry. So in the training phase, we are not going to have x0, right? we are only going to add one value, first value, let's say. We are going to predict the second value, and we are going to get the first value and the predicted second value to the next unit. So first we are going to predict y0, and then we are going to give this predicted y0 to this next layer, and then we are going to predict y1, and then we are going to give this predicted y1 and the hidden layer, and also y0 will also carry in the form of hidden vectors. There will be some information regarding y0 also, and then this information will pass to the last layer, so we could make sure that we can able to get the pattern and relations between the previous inputs and the current input. So therefore we would able to find the relation. So now first let's now that we have understand the theory of RCNNs or RNNs, sorry. Now that we understand this theory of RNN, let's try to implement it. Now, very easy RNN. Let's try to do stock price detection. I'm going to go here. I'm going to say stock price. Let's try to do stock price detection very fastly. There is a module in TensorFlow, so you can easily use TensorFlow to do this thing. TensorFlow already has a pre-written library called, I think, RNN, simple RNN. Let's see. You can just go to tf dot, you go to Google and search it, tf.keras.layers.rnn. I think it's called simple RNN. Right? Sorry. So we have this simple RNN. Sorry for that. Right. So yeah, sorry for that. So I'll just go through Kaggle. Kaggle is I have shared with you Kaggle. You must have gone through it. Just go and search with stock price. I think you'll have Netflix stock price, let's say. So Netflix, you might have known about it. You can just waste a lot of time there. It is, it is a platform where you can watch and waste a lot of your time. So yeah, just go and click on new notebook, so you can use the data. It is actually stock data, I think, from 2002, maybe. Yeah, no, sorry, yeah, only 5 years, 2018, sorry. Right, so we have stock data of Netflix from 2018, so we can just understand the patterns, right? So we can just understand how this data is going out, how this data is changing over time. We can just understand that using, let's say, RNN model. I've told you about RNN. It's actually pretty simple. You'll have this units in time, and then you can just pass through the hidden state, and there will be some relations that will be tracked within that hidden state, and this hidden state values will be changed based on this previous value. So there will be uh, some gradient based for each input. So therefore we can just find the patterns or the relations. But still there is a problem. I think I'll tell you about that in the next video maybe. There is problem called vanishing gradient. We can right, we can just this problem, the vanishing gradient problem, is that sometimes the model will not give more importance to the previous layers. So let's say there is a word, very far behind in a sentence that is very important. Sometimes the neural network might not give that amount of importance to the words that are very far from each other. So therefore we should start we should use LSTMs. So LSTMs in GRUs, they are another architecture. And then after that we have transformers, which are current chatbots. So like if you think about chat GPT and all that, they're all transformer models. They are a little bit extension to RNNs. I'll tell you that also in the future videos. So yeah, first cell, you know about it. We'll just the Kaggle writes it for you. we'll have numpy pandas. We'll import these libraries, and then we'll also look at the data that we have. Now let's just create a data frame. Create a data frame using of this data, of this CSV data. We'll just convert this CSV data into a pandas data frame. So what you can do is we have already imported pandas as PD. So I can just say PD dot read CSV, read underscore CSV, and then I can just input the path of this file. Wonderful. And then I can just say df.head. Df.head, this function, sorry. So this function helps you to look at the top 5 values, I believe. Yeah, the top 5 values, I think. Let's just see. Sorry, there is an error. Okay. So seems like there is a spelling mistake or something. I'll just try that again. I'll remove that. Let's see. I'll remove that. Okay, again. Okay, there is no file. Why is that? Yes. Oh, I think I should put .csv here. Right. No, sorry. /nflx.csv. I forgot to put that. I'll just copy this again. Sorry for that. I mean, like, we should follow a lot of rules. Make sure to check what have you wrote. Right. That is why copy pasting is sometimes considered wrong in coding. You know, I took some courses. So yeah, here are the head files. So the top 4 files or top 4 top 5 rows. Right. So we have open. Right. So on that day, what is the open stock price? When it opened, what is the stock price value? And then when it is closing, what is the stop price value? What is the highest value that day? What is the lowest value that day? And then we also have some other values in the volume of the stock, how many stocks are being sold at that day, right? And then we'll have this close file, open file. So let's consider close file. So what is the stock price at the closing of a day or at the end of the day? That is what important to me. And then let's look at the tail just to see what type of data we have. So as you can see, the opening data is from 2018, and then let's say where the closing data is, and it's 2022 February, almost a year ago. All right, now let's try to plot this stock functions, in a like a plot. I'm just going to say plt. We're going to plot these values, how they look. We're going to say plt dot plot df dot, I think df dot close. So close value, I'm going to get the close value of the df, and I'm going to plot this value into a scatter plot. Yeah, sorry for that. An error. Close, there is no word close. Capitalize, that is a problem. Yeah, like you should have same case sensitive, and like you should have the same word as the variable. Yeah, you can see the stock price. It is actually pretty counterintuitive if you think about it. It started as very low, and then after that, after you got lockdown and 2022 and all that, it increased very high demandly, and after some time, people understood that Netflix is waste of time, and they dropped it. So as you can see here, it is actually pretty counterintuitive. It increased because of the lockdown, and then it is actually pretty low before, and then after that it increased, especially as 2021 and 2022, and then it dropped. Right now you can just look at that. So now our goal is to predict what happens next, what happens after 2022. Maybe you can just check on the web if our predictions are true. So we are going to predict on this data using a RNN model, and then we are going to predict whether it's going to increase or not. So now let's just build a model, right? Sequential. We'll use a sequential API to build the model. Now let's build this simple RNN. And then, so I have the simple RNN. So what is the input of this simple RNN means? I can just input the number of hidden units, or the number of hidden or the number of layers, or the complexity of the model at each unit. So we have many units, and the units will be equal to the number of time series, or the sequence, the length of the sequence that we have. So can just input the number of hidden units, or number of layers, or the complexity of the model. Let me just say 100. I'll just try 100. I think I should say return sequence is equal to, right. And now let's do a normal dense layer with one output, right. We'll have one output, right. Then the next output in the case. So we have forgot to import TensorFlow. I'll just import TensorFlow for you. Import TensorFlow as TF, and then we'll run it. Right, we'll compile the model now. Let it run it. There's another error. Spelling mistake again. I forgot an A there. I'll just compile the model. Let's use the Adam optimizer, right? And then the loss. Let's use the loss as mean square error, the classic loss, and then we'll set the metrics to be metrics equals. We don't want the metrics. We don't want to use accuracy because we want the output to be as closer as possible to this actual value. We don't actually want to actually predict the stock price, the actual value in the decimal format, but we just want to get closer, right? So that is why I'm going to use the loss function and not going to use the accuracy. And then now let's train the model. I'm going to say model like history equals model.fit on df close. I'm going to train the model on df close, the close values, and then I'm going to that's it, right? Should I input anything? Yeah, the df close, the close values, and then I'm going to use epochs. I'm going to use the yeah, all right. Now that we have set the architecture, now that we have set the architecture and the base model model architecture in TensorFlow, first let's do some pre-processing to the data. As I've told you in the previous section, to have this down. Yeah. So as I've told you in the previous section, like we are in the training set, we're going to have x and pair of x and y values such that we could train the model. So now what we'll do is first we'll convert this data frame into numpy array. So now what we are doing is we are pre-processing the data, right? So first we'll convert this data frame values to numpy array, just for the fact that we can pre-process numpy values very easily, right? We could do indexing or all that. I'll convert the data into numpy array. So I'm just going to say data set is equal to df of close dot values. So I'm going to like this function, this attribute will just get me the numpy array of all the close values, and then after that I'm going to do is I'm going to initialize xtrain and ytrain as some as a list, right? So what I'm going to do is I'm going to do some loop. I'm going to say for I in range, what number should we spell it? Let's say 60, right? I'm going to explain this as we go on with the coding. I'm going to say data set. So I'm just going to go through from 60 to length of data set from the 60th element to the last value. On let's pick 30, just because I think our data set is small. Let's look at the length of our data set. Let's print data dot shape because it is a numpy array. That sorry, and see. Now let's see. Yeah, we have 1009 values. So I think let's say 60, man, or let's say 100. I didn't thought we had that much value. All right, let's say 100. From 100 to length of data set, I'm going to append this value. So I'm going to say xtrain dot append. What we're going to append is in the training data or in the data set from the I minus 60th element or I minus 100th element. What I'm going to do is, all right, so I'm going to get the, so let's say we have the number of stock prices, right? I'm just going to get my whiteboard fastly. I'm going to get this login very fastly. Right. So as I have told you, right? So what we are going to do is, we are just, let's say we have this data set, right? It is going to take some time. I'm going to leave it some time, right? So what is going to happen is, as we are going through extrain, so we are going to get the previous hundreds values, and then we'll just, so we are going to get the 100 values, right? From I, let's say from 0 to the ith value. So I is going from 100. So therefore we are going to get I minus 100 to ith value, right? I don't think it, yeah, I mean you understand the thing, right? There is no need of this. So you understand this, right? So we are going to, let's say I is 100 now. So the first iteration, let's say I is 100. So we are going to go from 0 to 100. So 100 minus 100 is 0, and we are going to go from 0 to 100. So this column represent 2. So the first number is the starting point, and the last number is the ending point. So we are going to go from 0 to 100, the first 100 values essentially, and then we are going to go through that, and then up to the final thing. And then what is a y train? What is output? Output is nothing but the final value, right? I'm going to say I. So we are going to get the first 100 values, and this is the input, the first 100 values from 0 to 100 values, let's say, and then output is nothing but the ith value. Understand, right? And then we are going to do that for all of these values from 0 to 100. All of these possible sets of consecutive values and then outputs. I'm going to convert this into numpy arrays, right? Because that's a very laughable and funny fact that, TensorFlow cannot operate on list. We have to do numpy arrays. I think they might have changed that, maybe, I don't know, but it's a very funny fact that TensorFlow is actually a very big library developed by Google, but it cannot take lists as inputs. But we have to convert this at numpy arrays. So we are going to have do this. We're going to convert this extend into number of extend. We're going to convert y train into number of y train. Understand that? Hopefully we have yeah, we have designed the model. We have all written the architecture and all that, and we have also designed the data set. Now let's train our model. Let's input xtrain and y train, and then let's train for, let's say, 100 epochs maybe. Yeah, let's try for 100 epochs. Now let's run it. There's an error, sorry. But training going through, yeah, probably with shapes, I think. I have 100 returns equals is equal true. Okay, let's see what is the shape of this extend and y train is. So I'm going to print the extend dot shape, the shape of extend. Let's see. Well, it is 909 by 100. Wait a minute. Is there anything wrong with that? Uh, I don't think so, right? So we'll have 909 values. Let's just look at extend. What values does it hold? The stock prices. Actually, right, and white train. What are the what is white train dot shape? I'm going to delete this line. Oh, okay. I'll try reshaping this value. White train dot, we not reshaping literally. I'm going to add another new dimension. No, sorry. I think it is -1 1. So I'm going to reshape this white train, and now let's try it again. Will it work? I don't think. I don't think so. Run it. Yeah. Um, by layer expected 3-dimensional and found 2-dimensional. Okay, let's try let's say input shape equals, let's say changing the input shape. Maybe I'll just shape x train 0 dot shape. Let's try the input shape as x train 0 dot shape, the first element shape. Okay, what is that problem? Is that problem with one-dimensional data or something? That let's try this. Okay, let's see what is the shape of extend zero dot shape. Yeah, we are going to look at that. So you might have figured this out by yourself. Let's see what we get. Yeah. Okay, let's try reshaping extend also. I don't think this will work, but Andrew and Jay, you might have known him. He said that don't have first rank arrays. You will always have uh, like two shapes, two numbers in a shape. Very well. Work none by one. Wait a minute. Let's look at what the value holds. Let's look at extrain, what it actually is. I think we have did any mistake in this pre-processing step. But we have these values. I don't see what is the problem there. Let's just run it again. Uh, let's restart it and like it run it again. See if it works. And then if it doesn't, like we'll just run it again. If it doesn't, we should try something else. We'll start from some. I think there's a problem with the shapes. We'll have 100 inputs. Okay. Okay. I think it is. Yeah. I think it is a fact with. Yeah. I think it is the fact with the number of hidden units. Let's try 10. I don't think we should use many hidden units. Okay. Again, expected endim equals 3. So it expected three-dimensional input. Okay. Okay. Let's see how we can add another dimensions. Let's try how to add another dimension to a numpy array. Let's see. Okay, let's try np.x expand dimensions. Let's try. Hope it works. Let's hope it works. Let's try this. X is equal 0, I think. 0 axis. Now let's look at extend dot shape. It will work now, I think. Extend 0 dot shape. 100 only. Let's say x is equals 1 equals that. Now let's try it. So I'll just, it's actually x is 0. Let's restart and run it all. It's actually, you should restart and run it all because you get errors a lot of time. When you have already run it and run it again 2 times. I'll just run it all again with this changes. Hope it works. Run it all. Yeah. Or arrays contain same number of samples. All right. I don't think this is the right thing. I don't think this is the right thing to do. There is no need of doing expanding dimensions. There is no need of expanding dimensions. I think it is a, let's see. I'll try to solve this or I'll come up with it in the next video. The video is getting larger, but okay, expected 2 dimensions and wait, extra. Okay. Okay, the first, even the okay, only the first sample has this shape. I don't know what is extrain dot shape. I think there is a problem. Okay, this is a problem. Uh, ah, sorry for that. Android. You know. Okay, so this is a problem. We have. I think I have found a solution here. I think. Let's remove that. That seems not work. So I'll try it again one last time, and then if it doesn't, you know, we'll try. But I'm going to restart and clear all the outputs. Let's try it for the last time. Hopefully, it should work. Mhm. Mhm. Okay, again, what is extend zero dot shape? It is actually 100 comma 100 comma. Should I try one? Let's say maybe network. No. Okay, so I'll just let's do it one more time, one last time. Let's see if it works, and if it doesn't, I'm going to and if it doesn't, we'll stop it. Okay, guys, welcome back. Okay, so for trying a lot of time, I found this line. So I have told you, the expected array is three-dimensional. We have tried to reshape it, but I don't know, it didn't work. And there is another function in numpy called reshape. So what I have did is, what I have done wrong is, we had a two-dimensional X train. So we only had 909 by 100. So 909 is nothing but the number of training samples, and 100 is the um, number of time series, right? So the input time series. So yeah, the mistake I have done is, we did not added the extra one dimension. We did not actually added the extra one dimension. So Andre is right. He had given a amazing advice for us. So the thing is, you should add the extra dimension. So if I run it now, it works, right? So there is no problem with the input shapes. Now let's compile our model again. Now let's run it. Train our model. Okay, it is training. So yeah, the numbers of loss are, the loss is quite high now, but don't worry. Like, we have a lot of training samples, number one. So yeah, it is getting out of control losses. But let's see if it does increase. Wait a minute. 100 now. Okay, so training is done, I think. Yeah, so yeah, as you can see, we have a lot of loss, because while training the model, I have used only one hidden state. Let's say 100 hidden states. Let's say 100 hidden states. Maybe we can find better features, hence leading to better loss, lesser loss. Okay, I'll just compile the model. Right now, let's run it. Hopefully, after trying for a lot, let's see if we can decrease our loss function. Actually, decrease our loss function. Okay, now we are getting some decrease. 16,000. Oh, wait, 1,60,000. Yeah, I mean, like, yeah, the loss is pretty high, crazily. But yeah, I mean, like, look at this. We are able to get down to the loss function. It's actually amazing, because as we have a lot of data points, there can be a lot of loss, and then we cannot be quite accurate, I believe. So yeah, 85,000, amazing. Why not, right? 70,000 loss function. It actually amazing. We are getting some very good results. Yeah, I mean, like, the loss is falling definitely. It started off with 1,90,000, and currently we are getting to 45,000. The loss is just 45,000. Even though the numbers are quite high, we can like, the performance is pretty good. Now let's finally try 200 hidden states, and let's try for 200 epochs, just to see whether if it works. My computer is also heating up. Let's compile the model. Now finally train it. Hopefully it gets down very low, very fastly. Hopefully, yeah. You can just stick with me in the training. Wow. Yeah. Yeah. I mean, look at the improvement, right? If you increase the number of epochs and the number of hidden states, you are getting a huge number of improvement. If you only have one hidden state in the case of simple RNN, right? When we are running first, we had only one hidden state, by the way. It didn't work that good, but now, as you can see at the results, we are getting quite amazing results. The drop is pretty amazing, and we have as we have a lot of epochs, I think we might be able to get to 30,000, 20,000 loss maybe. Let's try 20,000 loss. Let's see if we get to 20,000. Yeah, five. We have wait. We have got to 55,000 already. I think we can get to 20,000. 39,000, 38, 37,000, 35,000, 34,000. Let's try 20,000, or probably, yeah, 20,000. We have beat 20,000. Let's see where we'll go. Let's see where we'll go. 24,000, 23,000, 23, 22, 21, 21, 20, 20,000, 19,000. There is some time. It might take some time. You can just leave, I think. This is it for this video. So just just stick with me to see how much the loss will decrease. Yeah, 14,000, 30,000. We got a 13,000, 12, 12. As you can see, the model is pretty accurate, right? So we have a lot of values. We have a lot of data points. Now we have a lot of data points actually, but still we have performing that very good, like 10,000, like amazing, right? So if you have invested using this model, you'll only lose 10,000 rupees, let's say, because the difference is only 10,000. So if you just invest every time based on the function, no, the difference is actually pretty low, only 89, 8,000, only 8,000, sorry, 7,000 only. So it is actually amazing. Like, so it is actually able to predict each step of Netflix, which is like amazing. Like you can use it as a suggestion. You can use this model as suggesting stock functions or stock prices, which stock you want to buy. Like you can just use this for for suggesting, like, well, will it increase or decrease? Does it have a high chance of increasing or decreasing? Yeah, we're going to getting to this 170th epoch. It might take some time. It does take some time, because we have a lot of data points. Yeah, yeah, 180th data, and yeah, 5,000, amazing. Yeah, we are getting some very good degrees. So meanwhile, let's code the last. Let's just try to plot this. Yeah, let's just try to plot this. Let's using the PLT. I'm going to say PLT dot plot history of loss. Let's plot the loss function, how the loss is increasing or decreasing. I'm going to say PLT dot plot. Okay, the final loss is only 4,000. And yeah, and look at this loss. We are getting like a I don't know, like a logarithm function or something. I don't know, like a curve function, not a linear function. But it's amazing. Like we're getting huge loss, and it's actually pretty counterintuitive. You can just intuitively understand that at this part we are getting the high amount of optimization, and as we reach 175th and 150th epoch, the decrease rate is of course getting smaller and smaller. And as you can see, we got from 1,90,000. So the loss was actually 1,90,000. So there is difference of 1,90,000. Now we have got to 4,000 rupees, or 4,000, yeah, 4,000, not rupees but 4,000, like dollars. I think $4,000. The difference, also predicting higher and lower. And thank you for watching. And as you can see, we have built a successful stock price predictor. And yeah, thank you for watching, and I'll see you in the next video.